Hello friends, today we are going to discuss one problem which was asked in International Mathematics Olympiad 1959. This question was problem number 2 of that question paper, and this question was from basic concept. And the question was such that for what real values of x this given equation satisfies. For different values of a, and they had given three cases where first they had taken the value of a as root 2, then a as 1, then a as 2. So we will solve it first of all in general for a, then we will take for c for different cases. So before starting the solution, please like the video if you like the solution, and also subscribe to my channel for more such videos. So let's start the solution without wasting any time. First of all, when I am going to start with the solution, the first thing I am going to do is, because this 2x minus 1 is inside the square root, so I will write as 2x minus 1 must always be greater than or equal to 0. Whatever our solution comes out must be such that no term in the given equation or question must get undefined or not defined or anything. So likewise, if I solve it, it will come out to be x is greater than half. So that means I can assure that x will be positive. So x is greater than or equal to half. This is one of the set. Now let's start with the solution. Since a is also all the given values are positive, and obviously a should be positive because these are square roots. So square roots values are positive. So summation must be positive, or else if it any case were to be negative, then directly we had said that no solution for that case. So I'm going to square both sides, as well as there is equality, so we don't have to fear about that. So since now let's square both sides. What I'll get? Square of first term, square of second term, 2 times product of both terms. I'm just not writing the square root of parts because that is a we know about what is in that, so I'm just skipping for saving our time. Equals to a square. This third part will get cancelled out. Now 2x plus 2 square root of, this is x plus square root x minus, this is of the form a plus b multiplied by a minus b, so we can use a plus b into a minus b equals to a square minus b square. So x square minus b square, that is square root, will get cancelled out, so I can write 2x minus 1 like this equals to a square. Now let's solve it further. 2x plus x square minus 2x plus 1 square root equals to a square. Now 2x plus 2, this is nothing but x minus 1 whole square equals to a square. Now one thing students do mistake over here, that they write square root of x minus 1 whole square directly x minus 1, but that is wrong. If I write like this, then it's absolutely wrong. We should always write with modulus sign. So this was the key point in this question, that's why I shared this. 2x plus 2 times mod of x minus 1 equals to a square. Now we will check for different cases. Let's check for the cases. First case is a equals to root 2. So if I write this, 2x plus 2 times mod x minus 1 equals to a square, that will be 2. We can cancel out 2's. X plus mod x minus 1 equals to 1. Now you can see that we can split x plus mod of x minus 1 into numerous cases. We would have split this term here itself, but let's split here. If I write x plus mod of x minus 1 in the piecewise function, then first of all we will define for x less than 1, because modulus is the thing which is forcing us to write this function in the piecewise function. So we will split this function in the intervals at which the modulus is getting problematic, or the critical points. So when x is less than 1, it will be negative, so we will write it with a negative sign. Now for positive, x plus x minus 1, so it will turn out to be 1 when x less than 1, and 2x minus 1 when x is greater than or equal to 1. So now we have to check for the values when this quantity, that means this quantity, turns out to be 1. So for all the values which is less than 1, it is going to be take value 1. And so in this segment we are getting all the real values, that is x less than 1. And in the segment x greater than or equal to 1, we are going to check, that is 2x minus 1. 2x minus 1 equals to 1. Are we getting any solution in this set? If I solve, x equals to 2, which gives us x equals to 1. And obviously, if I take the intersection of this set and this set, we are going to get one element, that is singleton set, and that is 1. So the solution for this set will be x belongs to minus infinity to 1 close bracket, because 1 is also has to be included, because 1 also satisfies, and all the real number which are less than 1 also satisfies because it directly gives 1. That is a constant part. So for the first part, that is a equals to square root of 2, the solution is x belongs to minus infinity to close 1. Now let's solve for the second part, a equals to 1. The function was, let's rewrite over. The function was 2x plus 2 times mod x minus 1. 2x 2 mod x minus 1 equals to a square. Here 2x plus 2 mod x minus 1 equals to a square by 2, and since a is 1, so sorry, what I did, it is 1. X plus mod x minus 1 equals to 1 by half. I have divided the whole equation by 2, so I get this. We already split this, so I am not going to explain it once again. When we will split this, we will get x less than 1 and x greater than or equal to 1, we will get 2x minus 1. Obviously for x less than 1, the values are 1, so we want to achieve half anywhere. And for x greater than 1, let's check whether we are getting or not. 2x minus 1 equals to half. 2x equals to 1 plus half, that is nothing but 3 by 2. X is 3 by 4. Now we have to check whether these value lies in this set, that is x greater than or equal to 1. So if you check, 3 by 4 is smaller than 1, not greater than or equal to 1. So we are not going to get any solution in this segment, because for 2 x less than 1 there is no solution, because for all the values of x it will give 1, and for x greater than or equal to 1 it would have, this function would have given half when the x in the domain part would were present, that is 3 by 4, but 3 by 4 is not present in this domain set, so that's why it cannot take the value half. That's why no solution in this segment. I am writing here no solution. Now let's check for the third part, that is a equals to 2. Similarly, I am directly using from taking the function over here, 2x plus 2 mod x minus 1. What is a square? That is 4. Now let's divide by 2 equals to 2. Now let's write this in a split form. X plus mod x minus 1 equals to 1 when x less than 1, 2x minus 1 when x greater than or equal to 1. For x less than 1, it is taking the constant value, that is 1. Obviously that is not equal to 2. So we will check for the values in the second segment, that is x is greater than or equal to 1. So let's equate 2x minus 1 equals to 2, 2x equals to 3, x equals to 3 by 2. Now let's check whether it is greater than 1. Obviously 3 by 2 is greater than 1, so this satisfies this. So there is one solution, that is x is equals to 3 by 2. So for the C part, that is a equals to 2, we have one solution, and that is 3 by 2. So let's recap. For the first part, a equals to root 2, we had got infinite number of solutions, because that given function turns to be a constant for a interval, that interval was minus infinity to open 1, and also it gave the same value for 1, so close interval 1. Now for the B segment, when I solved, you clearly saw that 3 by 4 didn't came in the interval close 1 to infinity, because 3 by 4 does not belong to interval close 1 to infinity. That's why no solution. And when I solve here, it is clear that 3 by 2 belongs to interval close 1 to infinity. That's why this is a solution. So this was the basic idea, that square root of x square must be written as modulus. I am writing over here once again. Modulus of square root of x square is equals to mod x. Some students write it as mod of square root of x square equals to x, but this is absolutely wrong. This is correct. And for this point, I just discussed this question because it was worth discussing. So I hope you enjoyed the solution, and you have the clear concept right now. So if you like the solution, like the video and subscribe to my channel for more such videos. Thanks for watching.